This video is for problem number 8 on the review. Go through the different examples here and work through this. It's a pretty tough problem. So you got to make sure you're labeling everything carefully as you work along the way. So we have a picture, and it's always good just to double check to make sure everything they give you is on the picture. In this case, it is. And so I see it's an oblique triangle, and I have an angle side pair. So as long as I have that angle side pair, I can use law of sines. So it says find the size of angle ABC. So my equation is 70 over the sine of 78 equals 50 over the sine of theta, which is my ABC. Cross multiply and solve. I would encourage you to just do this on your own in your calculator. You get theta equals 44.3. Remember, we're finding an angle, so you have to hit second sine at the end. And then it says find the area of the triangular field. So if this is 44.3 and this is 78, that leaves us with 57.7 for that angle. So I can do my side angle side area. So the area is 1/2 AB sine of C, or the sine of the included angle. And our area ends up being 1,479. So 1,480 meters squared when you do this to the correct number of sig figs. And then the last one here says find the length of BM. So that is this piece going right down through the middle here. Okay, so I have a, if it helps, draw a separate triangle. And it says M's the midpoint, so that means this side is 25, this is still 70, and the angle in between is 57.7. So I have a side angle side. I don't have my angle side pair, so I can use cosine rule, and this is the side I'm going to find. This is BM. So BM squared, which is my C, are the two opposite sides. And you just plug it in, cosine 57.7. So BM squared is, again, punch these numbers in your calculator and make sure you're getting them. ... So when I take the square root of that, I get 60.5, and that's meters. So all that information from up here is going on the picture down below. So if you notice, this triangle ABC is on the ground here. Now there's a three-dimensional triangle looking up. So I can use any of that information, especially that first thing we found, that BM was 60.5. So I'm going to put that on my picture. Sure you can read that. And they tell me that N is the midpoint of the mast, so I have a midpoint there. And I have a right triangle that's an angle of elevation kind of triangle popping up off the ground. And then I have my triangle that's on the ground. And so the question here says, calculate the angle of elevation from N to M. And so I have to do that in a couple different ways. So I have to break this thing down into parts. So the first thing that I can do is, in my right triangle, I know that I have the bottom of the triangle, which is the adjacent side, and I want to find the opposite side. So opposite and adjacent is tangent. So the tangent of 63.4 equals BT, the whole thing, over 60.5. Solve that by multiplying both sides by 60.5. So BT is 120.815 But what I'm interested in is finding BN, because I want to look at the angle of elevation in this triangle. Okay, so again, I'm going to take and draw that triangle out. And the bottom of the triangle is still 60.5, but the height of the triangle is BT divided by 2, because it says N is the midpoint of the mast. So when I divide that by 2, I get 60.4. Again, I did 3 sig figs. Keep it exact all the way through, that's fine. Just show your work. So to find my angle of elevation, which is this little angle right here, I'm going to do tangent. Tangent of theta equals 60.4 over 60.5. And if you notice, these are almost exactly the same. You get like 44.95. If they were the exact same, you'd be 45, but 3 sig figs, 45 degrees. Okay, so this is a good problem that mixes up all the different SOHCAHTOA sines, cosines in one.